In this video, we're going to be going over a request about vectors, but specifically 3D vectors. And we're going to cover three concepts. We're going to cover three concepts that relate to 3D vectors. So the first concept is going to be, well, this isn't really something vector related, but it is 3D related, and it incorporates the z-plane. So we're going to be graphing (3D) points. We're also going to be dealing with cross products, and I'm going to explain each of these when we get to them. Cross products. And then lastly, we're going to be talking about finding area with two vectors. Alright, the first concept we're going to go over is graphing points in the 3D coordinate system. So most of you guys are probably used to graphing things. Oh, that's not a very straight line. There we go. On two planes. So you have the y and you have the x. And you would normally graph certain points on this graph, but there's also a third plane called the z-plane, and it we represent it like this, and we call this an isometric. We call it isometric, and that includes your x-axis, your y-axis, and your z-axis. And I'm actually going to color code these just to make it easier for you guys. Red, we'll do maybe pink, and then we'll do purple. And often when we are graphing these points, certain points, we use something called a perspective box. So a set of points, or a set of coordinates looks like this. So for example, we could have 2, 3, and we add a third point, which represents the z on our plane. So now if we wanted to graph this, we would usually use a special kind of paper called dotted paper, but I'm just going to try to make a visual representation of like what this would look like. So I'm just going to go ahead and use this to represent our planes. And we're going to graph this here, and I'm going to show you guys how we're going to do that. Let's use blue. Okay, so first we're going to label our axes. We're going to do X, we're going to do Y, and we're going to do Z. So first of all, we are going to look at our first coordinate, and we're going to see we're going to come to, so this is positive x, and this would be going this way would be negative. So 2 positive, so that's going to be 1, 2. So right here, this is where we're going to stop. Now, from there, we see we have to go up 3. So 1 up, as in on the y plane. Now we have to go positive 3. This would be negative y. This is positive y. So just keep that in mind. So we're going to go 1, 2, 3, and then finally we have to go up 4, or positive z, and this would be negative z. So since it is positive, we're going to go up 4. So it's going to look like 1, 2, 3, 4. And now what we have is our point here, so we can just write 2, 3, 4. And what we do with this, we can now create something called a perspective box, which is a visual representation of the 3D shape formed by us plotting this point. So this is your perspective box, this is your base, and now all of your vertices are going to be raised by 4. So 1, 2, 3, 4. Here's 1, 2, 3, 4. 1, 2, 3, 4. And now we can connect these. I know it's a little hard to see, but ultimately we should get a box that looks like that. We can connect these. And that's just to help us kind of see this better. I'm actually going to just change the color of our point here. There we go. It would look something like that. It would look like something like that. You have the box here, you have your point here, and you just make sure you label your axes too. Now we're going to discuss something called cross products. And cross products are, it's a way where we can find the vector that is orthogonal to 2 other vectors in 2 planes. So I'm going to draw this isometric view here. So say you had one vector that's going, this is going to be kind of hard to draw, but let's say it's going out this way, and you have another one, and this one's going to be coming towards us. So kind of like that. And then this forms actually, that's a little bit more accurate. Straight. There we go. So 2 different vectors in 2 different planes, and then this is going to be a 90-degree angle right here. So the cross product between this vector, so let's just call this vector u, and let's call this vector v. So the cross product of these 2 vectors is going to give us a vector that is orthogonal or perpendicular to these 2 vectors. So it's going to be something like that. And that's considering 3D. So this is going to be 90 degrees. And then this would be 90 degrees too. Like that. And that's what cross products basically tell us. So now what we can do is I'm going to actually show you how to find the cross product of 2 vectors. So let's take, for example, let's say vector v, change that color, vector v is going to be 5, 2, 3, and let's say vector w, or vector u, sorry, going to equal -2, 5, 0. So now these are 2 different vectors in our plane system. Now we need the 3rd vector. That's going to be perpendicular to these 2. It's going to be orthogonal. So what we can do now is we can set up, and it's different than just your dot product. It's a little bit more complicated, more steps to it. So what I like to do is I like to line up my numbers 5, 2, 3, and then line up my other numbers for the 2nd vector, so 2, 5, 0. And what this does is this is going to help us kind of visualize how to get the cross product between these 2. So the first thing we need to do is, actually I'm going to write out the formula that we use. So the formula for a cross product is, so u times v is going to equal b1 c2, and then this is a1 b1 c1, and this is a2 b2 and then c2. So the formula says b1 times c2 minus b2 times C1 minus A1 C2 minus A2 C1. And then this is plus, I should have done this where there was more space. A1 B2 minus B1 or A2 B1. There we go. You guys are going to see this formula in action, but this is basically the formula that we use. So according to this, B1, so this is my B1 here, B1 times C2, well, we see that's just 2 times 0. So we're going to have 0 minus B2 times C1. So B2, this is my B2, this is my C1, 5 times 3, that's 15. So 0 minus 15 is negative 15. Now, this is going to get a little messy, so sorry about that. But I'm just going to color code it for you guys so that you guys can see it better. Now we see A1 times C2. So this is my A1. This is my C2. Well, that's 5 times 0. That's 0, so it's going to be 0. Then negative 2 times 3. That's negative 6. And then finally, negative 6. So it's going to be 0 minus negative 6, which is going to be positive 6. However, we have to consider this minus, which is going to multiply into the positive 6. So that's going to become negative 6. So negative 6. And now finally, we can do A1 times B2. So 5 times 5, that's 25, minus negative 4. So that's 29. 29. So this is going to be our cross product, and that's basically the vector that is orthogonal to U and V. Now, lastly, the last topic that I want to talk about is how we can find the area of a parallelogram using the cross product of two vectors. So when we have a plane, we're going to have our two vectors. So we're going to have, let's call this vector U. And let's call this, I don't know, vector V. You can't really see that. There we go. That's vector V. So now, what we can do is actually find the area of this parallelogram. I'm going to show you guys how to do that. This forms a parallelogram, and we can find this this area in here. We can find that. And what we do is first we have to find the cross product of U, and we have to find the cross product of V. And after that, we're going to take the magnitude of the cross product, and we are going to square root it. So using the example from a few, that we just used, the cross product, I think it was, believe it was negative 15, negative 6, 29. So if we were to use the two vectors that we used last time, which were 5, 2, 3. So let's say that was our V. And then our U was -2, 5, 0. So now we found the cross product of them, and we have this now. So if we want to find the area between the parallelogram formed between these two vectors, we have to find the magnitude of this cross product. So how we can do that is we're going to take the magnitude of this. So we can do area equals the square root of each of these coordinates. So we're going to square all of them. So we're going to do 15 squared plus 6 squared plus 29 squared. And now we can do area equals, let's see, let me bring out my calculator. Let's see, 15 squared plus 6 squared plus 29 squared. That is equal to 1,102. And the square root of that is 33. 33.196 units squared. And that's how you find the area of a parallelogram using two vectors.